In this presentation, we're going to look at how to use the normal distribution to approximate the binomial distribution. So, in a large portfolio, 65% of the policies have been enforced for more than 5 years. An investigation considers a random sample of 500 policies from this portfolio. Calculate an approximate value for the probability that fewer than 300. Now just actually watch the wording here very carefully. That I'll tell you why later on. Fewer than 300 of the policies in the sample have been in force for more than 5 years. Okay, so let x here be the number in force, be the variable to describe the number in force for more than 5 years. Okay, so that's a definition of success. Okay, and the probability of that success is 0.65, and we have a sample of 500 there. Okay, so it's a binomial random variable with parameters n equal 500 and p equals 0.65. Okay, now so these are useful here. So essentially what we're going to do here is determine the expected value of x and the variance of x. Now the reason for that will become clear shortly, but the variance of x, let's just write it in like that. I'm going slightly out of shot there. Anyway, so n times p, which is 500 times 0.65, which gives us a mean of 3.25, which is our expected value of x. And the variance here is n times p times 1 minus p, which is 500 times 0.65 times 0.35. That gives us a value there of 113.75. Okay, now so we're going to evaluate this using the normal distribution. So essentially what we have to do here is justify it a little bit. So n, the sample size here is very large, it's 500. Okay, so we can approximate x using the normal distribution. Now just make some sort of quick mention of the central limit theorem, just to sort of say this is the theorem that provides the basis for using the normal distribution to approximate the binomial distribution, just to sort of demonstrate that you know where it's coming from. Okay, so I just wrote it in there as the central limit theorem, but really just put in a little sentence just to sort of go for the A1 answer. Okay, so essentially what we're saying here is using the normal distribution. The normal distribution is parameterized using the mean and the variance, or here, which is the standard deviation squared, because we actually will use 10.655 squared. That is simply the square root of 113.75. Okay, squared. Okay, now the reason we do that is just to actually make it as obvious what the standard deviation is, because that's the figure we actually use. 325 and 10.665. Now, earlier on we were told fewer than 300. Okay, not less than or equal to, fewer than 300. Okay, so when we're using the normal distribution, what we have to do is apply a continuity correction, which means either adding or subtracting 0.5 depending on the situation. So what situation are we talking about here? We are talking about this situation. So there we subtract minus 0.5. Okay, so that's why the wording there is very important, because it's not this situation. Really, you might not really lose a whole lot of marks out of that. Do you know what I mean? I put in a big table there just to sort of set out all the possible scenarios. But this is important, but really, you know, it's not as important as sort of saying that we're using a central limit theorem. So just try and get it right. Okay. Hopefully you might have it in the tables at the back of the exam paper. Okay. So we're in the home straight here. The probability of x being less than 299.5, that is the z-score, is calculate the z-score. Probability of z being less than 299.5 minus 325 or 10.665. Just to sort of state what z is, it's the standard normal random variable. Okay, so essentially what we have there is probability of Z being minus, sorry, the Z score there is a minus 2.39. So phi of minus 2.39. Okay, my minus signs are missing. Okay, and it should work out as an answer of 0.0084. Okay, now, so again, just to be clear, the Z score there should be minus. That's just a little typo there. So if you're familiar with the R programming language, you can just check your answer there using that. So that gives the 6 decimal places according to my setup there. But really, 4 is probably enough for that, an answer like that. Okay, we'll leave it there.